In this video, we're going to learn how to calculate the mechanical advantage for a wedge. Remember that a wedge is basically like a movable inclined plane. The mechanical advantage for the wedge is calculated by dividing the length of the wedge by the width of the wedge. We can see that in the equation below. We're going to apply this equation to solve this problem. A force of 800 pounds is required to split a log for firewood. The wedge is used to split the log, and it is 12 inches long and 1.5 inches wide. We need to calculate what the mechanical advantage of the wedge is, and we need to calculate how much effort must be applied to split the log with this wedge. To begin with, we need to diagram this problem. We're going to draw our log that needs to be split. It requires 800 pounds of force to split it. We're going to draw our wedge. Our wedge is 12 inches long, and it is 1.5 inches wide on the blunt end. The effort that we're going to apply is on that blunt end, and the wedge is going to move into the log and split it apart. We're going to apply our mechanical advantage for the wedge equation, and we're going to apply our variables to solve for this equation. In this case, the mechanical advantage for the wedge is the length of the wedge, which is 12 inches, divided by the width of the wedge, which is 1.5 inches. Inches divided by inches cancel out, and we're left with a mechanical advantage of 8. We now need to calculate how much effort is required to split this log. In this case, we divide the load by the mechanical advantage. The amount of force required to split the log is our load, that is 800 pounds, and it's divided by a mechanical advantage of 8 from our wedge that we just calculated. In this case, 800 pounds divided by our mechanical advantage of 8 requires only 100 pounds of force to split this log. Now, what if we have a problem that's set up a little bit differently? In this case, a force of 900 pounds is required to split the log for firewood. If you can only apply 150 pounds of effort to the wedge, what is the minimum mechanical advantage for this wedge? In this case, we're going to be using the effort equation, though we have to rearrange it in order to solve for mechanical advantage. To do this, we need to isolate mechanical advantage as a numerator, and therefore we have to substitute in on each side. In this case, we're going to multiply mechanical advantage on both sides of the equation. When we do this, the mechanical advantage on the right side of the equation is both in the numerator and in the denominator. These will cancel out, and we will be left with the equation of mechanical advantage times effort equals load. We then need to isolate mechanical advantage by dividing effort on both sides of the equation. In this case, on the left side of the equation, effort divided by effort cancels out, and we're now left with mechanical advantage equals load divided by effort. We can now substitute in our known variables into this equation. In this case, our load is 900 pounds. The maximum effort that we can apply is 150 pounds. Pounds divided by pounds cancel out, and we're left with a minimum mechanical advantage of 6.